Production of electromagnetic waves HERTZ experiment. Maxwell's prediction was experimentally confirmed by Heinrich Rudolf Hertz in 1888. Around 22 years, the Maxwell's prediction has to wait for its confirmation. Welcome to Physics for Everyone. Here we are going to learn about Hertz experiment and the properties which are proved by Hertz experiment. Here you have an LC circuit. This LC circuit gives electrical signal with the frequency nu equals 1 by 2 pi root LC. The output of the LC circuit given to an induction coil which has a primary turns and secondary turns. The secondary turns has more number of turns than the primary, so you will be having a high voltage output, oscillating voltage output. This output is given to two metal spherical balls. They are connected to a very large plate. The gap between these two metal surface is 2 centimeter and the dimension of larger plate is 40 by 40 centimeter. The experimental setup consists of two metal electrodes which are made of small spherical metals. The small spherical metals are connected to larger plates. The ends of the small spherical metals are connected to induction coil with very large number of turns. This is to produce very high electromotive force between S1 and S2. The coil is maintained at very high potential. Air between these electrodes gets ionized and a spark, a discharge of electricity is produced. S1, S2, it's given to a very high oscillating electric field. This high oscillating electric field produces a sparks between S1 and S2. This high oscillating electric field ionizes the air between S1 and S2. The charge in the ions oscillates according to the high oscillating electric field. Oscillating charge has non-zero acceleration and the concept is accelerating charge produces electromagnetic waves. So, as the charge oscillates, it gives out electromagnetic waves. This discharge of electricity affects another electrode, ring type, not completely closed, which is kept at far distance. A detector is placed. The detector studies the gap. The gap is parallel to the transmitter gap. Then only the detector could able to detect the transmitted waves. So, between the two studs of the detector, you have a very small spark. This implies that the energy is transmitted from electrodes to the receiver in the form of electromagnetic waves. If the detector is rotated through an angle 90 degree, thereby the gap is perpendicular to the transmitter gap, then no spark is observed. If the receiver is rotated by 90 degree, then no spark is observed by the receiver. This confirms that electromagnetic waves are transverse waves as predicted by Maxwell's. The frequency of the LC oscillator, the frequency of the electrical signal nu equals 1 by 2 pi root LC. Now, when Hertz find the frequency of the electromagnetic waves, he finds that it's also equals to nu equals 1 by 2 pi root LC. Hertz detected the radio waves. Hertz computed the speed of the radio waves, which is equal to the speed of the light, 3 into 10 power 8 meter per second. Hertz demonstrated the following properties of electromagnetic waves. Electromagnetic waves are transverse in nature. We proved that by rotating the detector by 90 degree. Electromagnetic waves has wave nature. What are the properties of wave nature? It could undergo reflection, refraction, interference, and polarization. All these properties are demonstrated by Hertz. The frequency of the electromagnetic wave is equal to the frequency of the LC oscillator. Nu equals 1 by 2 pi root LC. The speed of electromagnetic wave is equal to the speed of the light 3 into 10 power 8 meter per second. Thank you, children.